Welcome to G Fun Facts Online. For millennia, the planet Mars has been an enduring crimson enigma in our night sky, a distant point of light that captivated human imagination. Today, thanks to a fleet of robotic explorers, that point of light has been brought into stunning focus. It's a world of towering volcanoes, vast canyons, and tantalizing clues of a watery past. In recent years, the pace of discovery has accelerated dramatically, and the latest chapter in Mars exploration is proving to be the most exhilarating yet. The most electrifying recent news comes from NASA's Perseverance rover, which has been diligently exploring Jezero crater since its landing in February 2021. Scientists chose this 45-kilometer-wide crater specifically because they believe it was once a lake, fed by a river, making it a prime location to search for signs of ancient microbial life. And it seems their bet has paid off. In a landmark announcement, scientists revealed that a rock sample collected by Perseverance contains what they are calling potential biosignatures, representing the most compelling evidence to date for ancient life on Mars. The sample in question is named Sapphire Canyon. It was drilled from a rock formation dubbed Chayava Falls back in July 2024. This particular rock, located in an ancient river channel called Neretva Vallis, immediately caught the attention of the science team. It had unusual leopard spots, small, dark flecks, and distinctive white ringed patterns that made it stand out. Using the rover's advanced suite of instruments, including tools named Sherlock and PIXL, the team conducted an in-depth analysis of the Chayava Falls rock. What they found was a fascinating combination of minerals and organic molecules. The rock is rich in organic carbon, which is the basic building block of life as we know it. It also contains sulfur, phosphorus, and oxidized iron. The leopard spots themselves were found to contain the iron-rich minerals vivianite and greigite. This is significant because, here on Earth, these specific minerals are often associated with microbial activity. Billions of years ago, this precise combination of chemical compounds could have provided a rich source of energy for microbial metabolisms. Now, while these findings are incredibly exciting, scientists are careful to emphasize that they are not yet definitive proof of life. It's possible that non-biological or abiotic processes could create similar features. Researchers are currently working hard to rule out these other possibilities. The definitive answer, the final verdict on whether Sapphire Canyon holds the fossilized remains of ancient Martian life, will likely have to wait. It will wait until that precious sample, along with others collected by Perseverance, is brought back to Earth for analysis in our most advanced laboratories. This incredible task is the goal of the Mars Sample Return Mission, a joint effort between NASA and the European Space Agency. The timeline for this highly ambitious, multi-part mission is still being finalized, but it represents the next great leap in our quest for answers. While Perseverance's recent discoveries have rightly grabbed the headlines, we can't forget NASA's other active rover, Curiosity. This car-sized explorer has been conducting a remarkable, decade-long mission in Gale Crater. Landing all the way back in 2012, Curiosity's primary goal was to determine whether Mars ever had the right environmental conditions to support microbial life. Early in its mission, it found a wealth of chemical and mineral evidence, confirming that yes, ancient Mars was indeed a habitable environment. As of late 2025, Curiosity is still operational and has traveled over 35 kilometers. It's been slowly but surely ascending the slopes of Mount Sharp, the massive central peak within Gale Crater. By studying the mountain's exposed rock layers, Curiosity is essentially reading the history of Mars page by page. Each layer tells a story about how the planet's climate and environment changed over vast periods of time. The dozens of rock samples it has collected and analyzed on the spot have provided invaluable data on the geological and geochemical evolution of the red planet. Another recent and truly pioneering chapter of Mars exploration was written by the Ingenuity Mars helicopter. Nicknamed Ginny, this small aircraft proved that powered, controlled flight is possible in the extremely thin Martian atmosphere, which is less than 1% the density of Earth's. Arriving with the Perseverance rover, Ingenuity was initially planned as a simple technology demonstration, scheduled for just 5 flights. It far surpassed all expectations. Ingenuity completed an astonishing 72 flights over nearly 3 years before its mission finally ended in January 2024 due to rotor blade damage. Ingenuity's success was a game-changer. It provided a completely new aerial perspective for exploration, acting as a scout for the Perseverance rover, helping to map safe routes and identify interesting geological features from the air. The data gathered from Ingenuity's groundbreaking flights is already being used to inform the design of future aerial explorers, not just for Mars, but for other worlds, like the upcoming Dragonfly rotorcraft mission to Saturn's fascinating moon, Titan. But the exploration of Mars is not just a NASA endeavor. It is a truly international effort. Several nations are contributing to our growing knowledge. China's first Mars mission, Tianwen-1, successfully entered Martian orbit in February 2021. It deployed the Zhurong rover to the surface in May of that year. Zhurong explored a large impact basin called Utopia Planitia, using a ground-penetrating radar to search for subsurface water ice. Data from the rover provided fresh evidence supporting the theory of an ancient ocean in Mars' northern hemisphere. It also revealed a major climate shift on the planet that occurred around 400,000 years ago. Although Zhurong entered a planned hibernation in May 2022 and has not been heard from since, likely due to dust accumulating on its solar panels, the mission stands as a landmark achievement for China's space program, and its orbiter continues to study the planet from above. In that same busy month of February 2021, the United Arab Emirates HOPE mission also arrived at Mars. As an orbiter, HOPE is dedicated to providing a comprehensive picture of the Martian atmosphere and climate. It studies the planet's daily and seasonal weather patterns, tracks its massive dust storms, and investigates how the atmosphere interacts with space. This is helping scientists understand the long-term process of how Mars lost its hydrogen and oxygen to space, which is key to understanding how it transformed from a potentially habitable world to the cold, dry planet we see today. The European Space Agency, ESA, has been a long-term player in Mars exploration. Its Mars Express orbiter has been circling the planet since 2003, making significant discoveries, including the first detection of methane in the atmosphere, another potential biosignature. More recently, the ExoMars Trace Gas Orbiter, a collaboration with Roscosmos that arrived in 2016, is conducting a detailed inventory of Mars' atmospheric gases, hunting for trace amounts of gases that could be linked to either biological or geological activity. All of these rovers and landers on the surface depend on a fleet of orbiters that provide a constant watch on the red planet. These spacecraft offer a global perspective and act as crucial communication relays, sending data from the surface back to Earth. NASA's Mars Reconnaissance Orbiter, or MRO, has been mapping the planet in incredibly high resolution since 2006, helping to identify safe landing sites for future missions and studying the planet's geology in breathtaking detail. The MAVEN orbiter is focused specifically on understanding how Mars lost its atmosphere. And let's not forget the veteran Mars Odyssey, which has been in orbit since 2001 and continues to contribute to our study of the Martian surface. So what does the road ahead look like? The future of Mars exploration is ambitious and multifaceted, with 2 ultimate goals: returning samples to Earth and eventually sending humans to the red planet. The Mars Sample Return Mission, or MSR, remains the top priority for the scientific community. This complex series of missions, planned by NASA and ESA, will involve launching a lander to retrieve the sample tubes collected by Perseverance. Another vehicle will then launch those samples into orbit around Mars, where a separate spacecraft will capture them for the final journey back to Earth. Analyzing these pristine samples in our labs will allow for investigations far more detailed than anything possible with the instruments on a rover, and could finally provide those definitive answers about past life. China is also planning its own ambitious Mars sample return mission, which could launch as early as 2028. Looking further into the future, the prospect of human exploration of Mars is becoming more tangible than ever before. NASA's Artemis program, which aims to establish a sustainable human presence on our moon, is seen as the critical stepping stone for an eventual human mission to Mars. And private companies like SpaceX are developing powerful, reusable rockets, such as Starship, with the explicit goal of transporting humans and cargo to Mars, with uncrewed missions potentially beginning as early as 2026. The latest clues from Mars are painting an increasingly detailed and dynamic portrait of our planetary neighbor. The potential biosignatures found by Perseverance have brought us to the cusp of answering one of humanity's most profound questions. Are we alone in the universe? The continued work of a multinational fleet of rovers and orbiters, combined with ambitious plans for sample return and human exploration, promises that the coming years will be a golden age of Martian discovery. The red planet, once a symbol of the unknown, is slowly but surely giving up its secrets, each one more fascinating than the last. Thanks for listening to Fun Facts Online.